All right, hello, my name is Brad Hoffman, and I'm going to be presenting for the Fugger Junior group. This group has decided to make a cryptocurrency trading bot for our senior capstone project for the University of Louisville spring 2018 semester. One of the reasons we chose this project is because cryptocurrencies have grown massively in popularity over the past year. On screen, you can see a bunch of the cryptocurrencies that have been created, and this is just a portion of them. There are now over 1,500 cryptocurrencies with a value of over $300 billion total. I'm sure most of you have heard about Bitcoin as it is most popular, and second to that would be Ethereum. By this time last year, Bitcoin had already surged almost 180% since the beginning of the year value. Ethereum, by this point in time, had almost surged over 2,000%. Clearly, money can be made if you know what you're doing. We decided that we wanted to take a further look at it and see if we could make some money off of it. So that meant diving into all the different cryptocurrencies, all the different terminology, and really learning how to do trading. This meant that we spent a lot of time learning technical analysis tools, such as moving averages and Japanese candlesticks. Once we finished researching different technical analysis tools, we settled on 3 that we felt like would offer great trading strategies for us. They also provided a lot of opportunity for learning. As you can see here, in the top left, we have the simple moving average. In the top right, we have a symbolization of a neural network. And in the bottom, we have an image of a pump and dump. These are all different tools that can be used in order to take advantage of the markets and have profitable trades. Today, I'm going to be showcasing the tools that we have developed over the past few months. First up, we have moving averages. On my right, I have a terminal screen where I will be executing some of our programs. And on the left, I have another terminal screen down here, as well as a code viewer and a file structure here. Within our source code, within our project, we have a bunch of different tools. We have some different utilities for scraping Twitter, for scraping Reddit, and then also for doing moving averages as well as correlations. First, I will be showcasing our moving averages. This code was written in order to calculate a moving average over a historical data set for the price of Bitcoin and other cryptocurrencies that we've downloaded. And now I can execute it, and I'm in the Python environment, and it is going to be a simple Python moving averages.py. So you can see that this pops up on my screen. This is a demonstration of the price of Bitcoin, which you can see in blue, a short moving average, which is based on the 5-day historical history, and then you have a longer moving average, which is based on a 20-day history. Down here, you can see the trading position. So when we have a value of 1, that is an indicator that we should go ahead and buy. And when we have a value of -1, that's an indicator that we should go ahead and sell. You can see that these switches correlate with the switches in the line, the crossovers in the line. Now, this program also does a trading simulation for us. We can see down here in the terminal that we have 2 different strategies going on, a moving average strategy and a buy and hold strategy. With this particular time period and currency, we can see with an initial investment of $10,000, our ending investment would be $43,102. With a normal buy and hold strategy and an initial investment of $10,000, we'd see that our ending investment is $40,490. Now, this is not taking into account exchange fees, which would most likely take away some of the returns that we see on these values. In another instance of moving average, we can change our Ethereum dataset to be a Bitcoin dataset. If we run the same thing, we'll also see different price ranges, and we'll also see different trading positions. Now, the important part here is that our moving average strategy does not perform as well as our buy and hold strategy. It proves way more valuable to simply buy Bitcoin at the beginning of the period and sell it when it's at the end. This is one of the downfalls of moving averages, as the returns are circumstantial to the periods as well as the type of currency that you're seeing. Up next, I'm going ahead and go and run our correlation script. So what this is basically showing is the price of Bitcoin versus the price of Ethereum. And the correlation, a higher correlation obviously means that they're correlated, and opposite obviously means that they're not. The x-axis is our lag. So this would be 2.5 days, 5 days, 7.5 days, and 10 days, and then the reverse. So what we're seeing here is for a jump in Bitcoin price, there is not much of a correlation to a price or a rise in Ethereum. In this next one, we are seeing the price of Bitcoin correlated with the Reddit subscriber growth for the Bitcoin subreddit. In this case, Bitcoin is pretty well correlated with Reddit subscriber growth, but Reddit subscriber growth would not be a good indicator of Bitcoin price growth. It's the other way around, where we see that a rise in Bitcoin means that there is probably going to be a rise in the Bitcoin subreddit subscriber growth. Lastly, I'm going to showcase our pump and dump detection. The most important part of this is the chart that I will be showing. Now, this is not fully implemented, but it gives a good indication that we might actually be able to detect pump and dumps when they occur, or when they are about to occur. This is the chart that is being displayed. Now, this is currently for the BTC and Tron pairing, which is a market on the Bittrex exchange. What you can see here in the red are the number of sell orders for the given pairing. And what you can see here in the blue, the price of one Tron coin in Bitcoin. So these numbers are actually really small. What it ends up being is about 0.06 to the -6 Bitcoin for one Tron. The most important part is what we can see here. When a pump begins to happen, we can see that the number of sell orders drastically declines. They happen almost simultaneously. What you can see here is that the number of sell orders begin to decline significantly before the currency even jumps. So if we can detect this drop in the number of sell orders, then we might be able to go ahead and buy in at a given point. Lastly, we have neural networks. When we run our program, the model begins to train based off the price data that is given. While this is training, you'll see in the end that our predictions aren't as good as they could be, because we're doing these predictions strictly based off of pricing. Whereas if we were to combine this with the open buy and sell order data, or potentially volume data for a given marketplace, then we could probably generate more accurate predictions for a market over an extended period of time. And what you see here is an output of the current predictions. You can see the difference in the light blue and the dark blue. The dark blue is what it was observed, and the light blue is what we predicted for our training set. Now, once the training was completed, we can see the prediction for our test set. So they are somewhat correlated, but not completely. This is what we see in our loss based off of value. So in the training set, we see a max loss of $15 or $16 per prediction. This means that at any point in time, our prediction for the training set would be $16 off what the actual value is. In our test set, this gets a lot worse, with almost a difference of $40 within our test set. And that is about it for our presentation. If you'd like to check out our source code, you can go to GitHub at github.com/Brad Hoffman 96/Fugger Junior.